I have a story for you. A story that started when I was writing my first book, Android Development with Kotlin. And the first chapter I decided to write was a chapter about delegation, because it's loosely related with other chapters and it's supposed to be pretty easy. And then it happened. I fell in love. My girlfriend wasn't very happy about it, mainly because I spent even more time in front of my computer writing code, what is hard when you already spend most of your time in front of computer. I had to think about it not only during the day, but also during the night and during most of my activities. But I felt really good, and I felt really inspired. And it was an inspiration with a feature I would like to show you today, and in more general level with a concept I would like to show you today, that is called a delegation. So to introduce you the concept of delegation, I will start from the less important brother, the interface delegation, that directly reflects how traditionally delegation was used. The interface delegation comes from the classic delegation pattern, where we need an object to implement the same interface as some other object, and we hold this other object as a delegate, and we delegate a set of methods defined on this interface into this another object. So this way, this Witcher player gets all the capabilities of RPG game player without inheritance. Basically, it was the idea, but in the easier way. This is an implementation of composition. If Witcher player wouldn't implement the same interface, then it would be just a perfect example of composition. When it implements the same interface, it's called a delegation. This feature is giving similar behavior as we get when we use inheritance, and in these terms there are many similarities between those two. But there are many problems with inheritance that we as a community are more and more aware of right now. And these problems, the main problem can be reflected on this very simple example. So let's say that we need to make our own object that will act like a hash set, but additionally it will count how much elements were added. And so we implement hash set, but we also override add and add all, and in add and add all we bump our counter, so we're supposed to know how much elements were added. So who thinks it's a good implementation? Nobody thinks it's a good implementation, so who can tell me what's the problem there? No, I would like only to count how much elements were added, not how much elements are there inside. So, what if I add something using add all? Yes, that's the general problem, and this is the answer. So if you can you pass this Mac to her? So if you use add all, elements will be added twice, and the reason behind it is that add all under the hood uses add method. What is a bit surprising, because it's not in the documentation of this method, but it's actually how it happens. And when we use inheritance, we depend not only on behavior, but also we depend on how this object is implemented internally. So we call it that inheritance breaks encapsulation. Of course, we can fix it by deleting this line, but what if now creators of hash set changed its internal implementation just to optimize it, and we have a problem right now. We have an error. So this is the big problem. This is a big problem in Java right now. Most Java objects cannot be changed at all because they were open, and many libraries depend on them. So this caused a huge problem, and it blocks many optimizations and many changes. So the very important and influential book suggests that we should avoid inheritance in many cases, and the three key cases are first when classes, of course, final private, are not designed for inheritance. So the problem is actually here. This class was not designed for inheritance. It allowed inheritance, but it was not designed for inheritance. And we should not use inheritance in this case. Another case is when there is a relationship. I don't want to elaborate on that too much, but it's always causing a problem in long run. And the second case is when we need only some functionalities. So when we use inheritance, we take everything. When we don't need everything, we might have some problems in the future. The general solution we use is to use composition instead. So we just compose this. We just have this object as a field. But we use delegation when we additionally need to have a polymorphic behavior, and we can achieve it by using interface. But delegation was hard in Java. And to support it, Kotlin introduced so-called interface delegation. So our first example can be fully replaced with this example. So instead of implementing these methods ourselves, we can just say that we want to implement interface player and delegate all methods from this interface into an object RPG game player. So this delegation is supported in many different variants. Basically, any object that is accessible at this scope, at the scope of class creation, can be used as a delegate. But in most cases, we rarely need to use this kind of polymorphism, so it's not a very popular feature. Though one very nice usage is when we implement the decorator pattern. This is a typical classic example of decorator pattern when we define how we read file using some input stream. So we first create file input stream, we wrap it up into buffered input stream that adds buffering capabilities. Then we wrap it into zip input stream that adds unzipping capabilities. We wrap it into object input stream, and finally we read this object, and by that we process it using all these objects one after another. Very typical Kotlin usage is when continuations are wrapped under the hood, or streams are using decorators under the hood when we use Kotlin streams. And in Kotlin, the problem is that sometimes this interface has a lot of methods, and actually input streams has a lot of methods, and we don't want to implement them all just to fill them with passing into our delegate, into the object we decorate. And it can be solved by using decorator pattern. Of course, in this case, it makes sense only if player has more than one method. But let's say that it has 5 methods, and right now you can just override a method you need to change, and all the others will work as they work in the delegate. So this is a pretty simple pattern, though not used so often because it's not a very common case. But there is that it should give you a sense how we use delegation, and you should start understanding how delegation works. And many other things can be delegated, and there is a very important delegation feature that is used widely in Kotlin, and it's called property delegation. To understand property delegation, we need to first understand property. So when you look at Kotlin property, it looks like a Java field, but under the hood, it's way more. It's like a field, but additionally getter and setter. You know there is a getter and setter because you can always give your own getter and, if you want, also setter. And usage don't change at all, either from Kotlin or from Java, but the behavior can be customized. So whenever you use property in Kotlin, it's encapsulated by default, and you don't need to do anything. When you want to use this encapsulation, you just add custom getters or custom getters and setters. Actually, property in Kotlin does not need any field at all. It can be composed only from getter if it is val, or only from getter and setter it is var. So this is an equivalent of getter and setter in Java. In Kotlin, this is just a get function and set function. And getting back to our delegation, we often use similar patterns for many properties. This is extreme property just for demonstration purposes, but you can think of many patterns like lazy property, observable property, when we need to observe when property changes or when you want to initialize property a bit later. And all of that is easily handled by property delegation. So how we can extract a behavior of printing that the field has changed in here? All you need is a following class that gives you get value and set value operators. And once you have such class, you can just use it, define a property and delegate to any instance of this class. So it's actually very simple. And since you know that property is getter and setter, you can imagine that getter will reference get value and setter will reference set value. But what are those other arguments? So this is the most important slide. If there is something unclear with delegation, I would like you to go back into this slide because it explains everything. It basically says what is property delegate and the usage compiled to. So when you use property delegate, there is a special field generated that holds this delegate. And there is, in getter, there is get value called. In setter, there is a set value called. And these two additional variables are a context, this, and the bounded reference to this property. This, if we are in a class, this is, of course, a reference to the class. If we are inside an extension function, because you can use delegating properties inside functions, this is a reference to extension receiver. Who can tell me what is it in the top level? Do we have this at top level? Nope. Any guess? What can we provide if we don't have anything to provide? It's actually null. So at top level it's null, and that's why I provided here this ref as any nullable, so it can be used at top level as well. So when we don't have anything, we use null. Here are a few classic problems that were fixed using. I wanted to show that property delegation is not a new problem. It's an old problem that used to be solved using annotation processing or some patterns that you use again and again. And these are very classic examples from Android. But all of those can be easily replaced with property delegates, and we don't need them anymore. So we'll see it in a minute. And we will start from talking about Kotlin standard library delegates. There are only a few of them, but they are very important. First of them is not null. So the classic problem is that sometimes we don't have a value during class creation. We need to provide it a bit later, like on init block. And if if we don't have any special support for that, we need to make this value nullable. What is not good in usage, we later need to use not unsafe casting. Of course, this is not a good solution. We can solve it by using late init. Though late init cannot be always used. It cannot be used for primitives. It cannot be also used from top level. So this is not a good solution. Implementing a backing property is ugly and very confusing. So instead of that, we can use not null delegate. It's actually in delegates object, so sometimes it's delegates.notNull, but we static import it, so we just use it by not null. And this way, we don't need to provide it. But of course, if we try to obtain this value before initialization, we'll have an error, like in late init. The implementation is very simple. We just hold the value. In get value, we try to get this value, and if it is null, we throw an error. In set value, we just set this value. So this is the simplest example of property delegation from standard library. You can find it very easily yourself. And yeah, this is a very simple example I wanted to show you. We generally prefer late init, but in some cases where we cannot use it, we use not null. So this is why this delegate is still useful, even though it's less efficient than late init. Another very common pattern is that, and I believe who have ever, I mean, this is a lazy initialization when you want an object to be initialized during getter instead of during class creation. Who have ever implemented this in any project like Java or many people? This is very, very popular. And to do it properly, it's actually hard. This is with a bit of synchronization, but this is not a good synchronization. Good synchronization is a bit more complicated. In Kotlin, you don't need it all. All you need is the following structure. You just make a property and you delegate to lazy. Lazy is a top-level function that returns a delegate, lazy delegate. And that's basically it. So it's kind of nice. I know there are many people from Swift world in here, and you have a modifier for that. In Kotlin, you don't need a special modifier because you have delegates, which are more general concept and can be used to replace this. Kotlin example, very, very classic one, is that in Android we used to have to provide bindings to views during on create, and so we used late init. Oh, okay. So we used late init. Of course, it's spread in many places. It's not clear, and we would like to improve it. And the very simple improvement is to use lazy, and on the end we have the same result. If we use it before on create, we have an error. If we use it after on create, everything works fine. It can be, of course, improved way more if we extract a very simple function that just returns a lazy delegate. All we need is a bind view, and that's basically it. So whole dagger knife can be summarized in this one line of code. So, this is the power of Kotlin property delegation. The same way we can bind pretty anything we want, including strings from extra, strings from strings, colors, extra string, basically everything. Many people like to do this kind of things, and it works fine. Another delegate is an observable delegate. It's like a value, mutable value, that also informs us, invokes an action whenever this value is changed. So here is a very simple example that just prints how value changed. And so whenever we change the value, whenever we call setter, we have this println called, and we print how value changed. So I believe you can imagine usages in projects, but here are few from my projects. One of them is when we when we change the content of some adapter and we need to notify that that dataset changed. Of course, in a good implementation, it should check how these elements change and do it in a proper way. But it can also be extracted into one function and reused in a project. I just wanted to show a simple example. Another one is when we bind the drawer open property, which is of type Boolean, with the fact that drawer is either open or close. So whenever we change value of drawer open, it forces drawer to open or close. And the last one is when I had a very complex view that required many presenters inside, and those presenters needed some life cycles. I just made this list, and whenever I added new presenter, on create was called. Whenever I removed some presenter or many presenters, on this tray was called. So this way, lifecycle was maintaining itself automatically. The brother of observable delegate is vetoable. Vetoable works very similar way, but additionally decides if new value should be set or not. So if it returns false, new value won't be set. And it's called before value change. So this is pretty clear. Pretty typical example is when we have some property with requirements, and we either accept those requirements and we set new value and we display it on view, or we don't accept it and we show some error. One additional example is from standard library is that map can be used as a delegate, and map with keys of type string. And it works very, very simply. So whenever we ask for a property, for instance, for a name, it searches on this map and it looks for a key with string name. And if it finds it, it gets it, it casts it to its type, and it basically returns it. So this way, if we have some maps that we want to parse into some object, we can do it this way. The very interesting thing that I would like to highlight is that map is an interface, pretty simple interface, and does not implement, and it does not have a method for get value. This get value is provided as an extension function, as a generic extension function actually. And yes, it is possible. You don't need to make an object a delegate, you don't need to have this operator inside. You can provide it as an extension function. So this way you can make basically anything a delegate, if you wish. And so this is what happened to map. As you can see, it checks the key by taking property name, gets a value by this key, checks if it is there, and returns it as a expected type. Also, mutable map can be used as a delegate as well. But in mutable map, we can also change this value. So we can use vars. Mutable map is mutable, so it can change. So we can also give set value. And so this way, mutable map can be used to hold mutable values as well. And I have a puzzler at this point. It's since I started making workshops, I started giving people puzzlers because the educational value is pretty high. It forces people to think and to challenge themselves. And I would like to challenge you by asking you what this code will produce. And here I have some possibilities, and I would like to give you half a minute and think about it, and then I will ask for each of those possibilities. What does it produce? people on YouTube can stop and think about it for longer. Okay, who thinks it's A? Who thinks it's B? C? And D? Okay, so the point is it's B. And who can explain it to me? Excuse me.
When we use delegate to create a population here, it keeps like a copy of that map and it uses it all the time. So even if we change a reference, it's still the same map.
Yeah, that's exactly the point. And the answer is on the slide I told you to always get back to when you have a problem with delegation. So when you look how it is compiled, you see that we don't reference to the same property all the time. We just reference to the value of this reference to this object, and we hold it in a separate field. So in this case, when you get back here, each of these properties reference to city, which is an immutable map that was passed as a cities. But no matter that cities changed, the property still points into old delegate. It's immutable. So we don't reference property. We pass the value as a delegate. So we would have to use mutable map and clear it to make it possible to empty that. And this is a very common misconception. But if it would be the opposite, if we would still reference this object, it would probably cause even more problems by unexpected changes when you passed some value, but then you haven't noticed that you changed it before, and it would probably cause bigger problems. So this is a design, and this is the solution for all questions about property delegation. There is also one more operator called provide delegate. So instead of giving delegate directly, instead of being delegate, we can pass this responsibility into another object by provide delegate, and this is supposed to be a delegate. So if we don't implement get value or get value and set value, but instead we provide delegate, our property will be compiled into the following implementation. So our user delegate actually provides delegate, which is another object. Pretty useful when you use intensively property delegation in your projects. When you see that, you can feel that you have unlimited power, and this is how I felt. And I started experimenting with different projects, with different ideas, and I started making libraries. And I would like to show them to you. They were all pretty experimental, but I found them very useful. And the first one is used for view properties binding. Right now we have view models, but back then they didn't work so well. And we had to use presenters and views. And what we end up was that all the changes on view needed to be expressed in interfaces. And of course, in our activities, we had to have a lot of small functions with a very small responsibility that is very repetitive, just to update something on view or to get something from view. And this can be improved by changing interface functions into properties, and then by making delegates that are binding those properties into some traits of the view. So in this case, we I bound progress visible to visibility of progress view, email to text on email view, password to text on password view, and in the library there is no link to library, but it's Kotlin and Android view. Okay. You can find it on my GitHub, but in the library I provided other delegates for binding different properties, and this is minimalistic and painless. And if you still use MVP, it's very helpful. Another case is preference binding. So the classic way to handle preferences is terrible. So you need to always get preferences, and to edit them you need to make edit and put something and commit. Also getting, you always need some reference to key. It's basically not user-friendly. So my first attempt to fix it was kind of crazy, because I made an extension properties with delegates, and these delegates use these references to these extensions. So when you use a delegate in extension property, this inside this delegate references to this shared preference, so you can use it to manipulate an object. And it was already a step forward, but it causes some problems. I still couldn't properly mock it for unit testing. I still had to have a reference to shared preferences. So later I made a new library where I had to hold all preferences in some objects, all preference fields in some objects. But since then, I could use it easily by making prev.property and editing it, reading it, just like any other property. And whenever you change it, under the hood, the shared preference field changes. So it looks like using a property, but it's actually reading and writing the memory. There are also some modes, so you can use caching to have this value faster and update it on the background. So yeah, it gives you a lot of possibilities. You can always turn on testing mode for unit testing, so you don't need to use this preference at all if you just do unit tests. Another good example is not mine, but it's a very nice library that was already referenced today a few times, and it has logo, so it means it's a very good library. And it's named Codain, and in Codain they use delegation to provide, to basically do dependency injection. So, and it also looks really nice, and it's really painless. So there are way more libraries right now using preference delegation, but the capabilities are still, in my opinion, highly unused. We still need to find out new things that can be optimized using property delegation. Though I would like you to spend a minute on thinking, what do property delegation really introduced into this world? Because if you generally think about the programming, like everything could be done in assembler, but the value in general is that something can be done easier way, without distractions and without additional boilerplate code. And to show what delegation introduced, let's compare it with other options that we might use if we wouldn't have property delegation. So first one is functions, but of course, as we might notice, functions does not hold state. So when we wanted to do something like lazy delegate, it's very clearly depending on a state, so it cannot be extracted using a function. So we ended up implementing the same thing again and again. The same in here. You probably can extract the function, like getting text and to string from email. But if very often, in general, the issue is when you need to hold some state, and this is something where functions won't help you. Another option is a class, and actually classes can fully replace property delegation, but they never want it because class is a way bigger concept and way more complex concept. So you could probably make a lazy property class and just instead of getting user repo, you would only have use user repo.getValue every time. And this is something you can do without property delegation. But the point is, it's just more complicated, and it's adding additional layer of complexity. So you never know what else is in this lazy property. Maybe there are some other methods that someone will introduce or something. So people end up preferring simple way and rewriting lazy every time. Also, looking at our other example with property, with view property bindings, our classes don't help so much. I mean, they might help, but then we need to define some interfaces to bind them because probably we cannot pass instance to as a main view. And in general, it's not so readable. What is this email? It's bind to text. What's bind to text? So it's getting complex and causes many questions. And when you use property delegation instead, it's clear. Email is a string, and it's bound to text. And the type of this email property is string. And if you want to mock it, you don't need to use this property delegate. You can just use a string property, and that's it. And that's it. So we still have a few minutes, and I will say 2 words about me. I am trainer, consultant, and author. And I made Android development with Kotlin, and at the moment I write effective Kotlin. I live from workshops, and all my workshops can be found on Code Academy, www.code.academy. And this is my initiative, so many people have asked me about it, and yeah, this is my initiative. And that's it. So that's your time for your questions. Thank you for your attention.
Hi, I would like to ask about 2 things. The first thing is about that observable delegate. Does it hold a strong reference to the variable that it's observable?
Does it hold strong reference? So it's okay. So the point is that the observable delegate. The question is why there is this property. Yeah. Okay. So it holds a bounded reference. Yes, it holds bounded reference. So basically, yeah.
So we should clear it on like I believe there is a case that we have. I know that at text view text we can observe some variable, and that variable can come from, I don't know, from anywhere. Should it be cleared, that observable property on destroy or on the pause?
No. I mean, if you clear this object, so normally it's inside a class. So once this class is garbage collected, we clear our properties. So we also clear our delegates, and there is no such problem. If this is at top level, so it's basically static. So it's like with statics, not so well cleared. Yeah, but in general, it's cleared with context. So.
And my second question is about that task that you gave us. There was a val, and if I'm gonna be changed to variables, the var, the result will be the same.
You mean on lazy? Wait.
No, the task with the cities that you gave to us to think about.
Yeah, the puzzler.
Yeah.
So if we would use mutable map, and in here, instead of setting cities equal to empty map, we would use this cities.clear, it would work fine. So in this case, we couldn't change to mutable vars because it refers to immutable map, and immutable map cannot change its value. So microphone. Do we have a microphone? Do you want to ask a question? No? Someone wants to ask a question?
So I was thinking about the example with bind to text or something. Does it not leak the view? So what if onDestroy view gets called on a fragment and then we still hold the reference to the text view? Shouldn't we clear it somehow?
So basically, under the hood, I just use a lazy delegate that gets value, and so it's the same as having lazy inside a class. So it's kind of the same question. So I believe that the result is the same as I answered before. So when you clear activity, when you don't use activity in normal case, you clear properties, so you clear delegates, so you also clear...
But what if it's inside the fragment and the fragment's view get destroyed, but the fragment itself doesn't get destroyed? So onDestroy view gets called and onDestroy doesn't get called. So like we detach the fragment and then we attach it once again.
It should be still there. It shouldn't be, it shouldn't be crushed by garbage collector. Oops. So okay. So the case is, yeah, probably it might be improved for this case. I later made a bit. Yeah, but it still holds it. I later did a bit different approach where I pass, instead of passing ID, I pass, in this case, progress view, so Kotlin Android extensions reference, and that I don't need to cache because it's already cached inside, so I don't hold anything in that. So it would, yeah, solve this problem, and yeah, it's on GitHub as well. I just wanted to show it as an example how property delegation can be used to solve easily some complex problems. I might have showed you how bind to visibility is implemented, but basically it's a very simple class, like, I don't know, 10 lines or something. No, nothing special there.
I just want to ask if we would like to improve that. We could pass maybe this like a fragment and get observer on view lifecycle, and we could null the value when onDestroy view is called, and then again bind it.
I think we can do that because you pass, you have a reference to. You have a reference to the context. You can make it to require this property to be used on life cycles, yeah, and yeah. So and then you can use inside this delegate something more. Probably it would be better if you would use provide delegate in this case to pass this context as to another object. So
okay, yeah.
Yeah. Yeah, so thank you a lot for your attention.